Okay, so section 2.7. This section starts out with what's called a midpoint. And there's two cases. The first case is if it was just one-dimensional, like say you had a segment from 2 to 10, and the midpoint is right here in the middle. All right, now sometimes you could figure it out without a formula, but the way you actually do it is you add the two endpoints and you divide by 2. So 14 over 2 would be 7. If you want it in the form of a formula, basically it's this. You add up the two endpoints and you divide by 2. One little note here, don't ever do this on your calculator. This will give you the wrong answer, okay, because it's going to do the division first. So be careful on the calculator. So it would work even if you had a negative. Let's say one of the numbers was negative, and you could end up with a fraction as well. So I just do the same thing, negative 3 plus 8 over 2, 5 over 2, and you could just leave it like that. That's fine. So that's the midpoint for a one-dimensional case. Now the next one is if you have two dimensions, like say a grid, and let's say for example 5, 4, and -2, -3. Okay, so in this case what you do is you add the x's and you divide by 2, and then you add the y's and you divide by 2. So basically you do what we did up above, but you do it twice, once with the x's, once with the y's. So if I do it with the x's, all right, so let's go 5 plus -2 over 2, that's 3 over 2, and that's for the x's. And it doesn't matter if I did -2 plus 5 over here, it doesn't matter. I'm going to come up with the same answer. And then for the y's, 4 plus -3 over 2 is 1 over 2. And so the answer is a point. So it's 3/2, 1/2. So 1.5 and a half. It's kind of hard to see where it'd be, maybe somewhere right around here. But basically that's what you do. You just add the x's, divide by 2, add the y's, and divide by 2. Okay, now another kind of problem is if they give you one point and the midpoint, can you find the other point? So like for example, let's say A is 3, 1, and the let's call it B. I'm going to call it B is 2, -5, and that's the midpoint. And then find C. So in other words, you have, like if I were to draw this out, you don't have to draw it out, but just to kind of give you an idea. Okay, so here's A, here's B, and that's the midpoint. And so the line would have to go like this, or the segment, and we're trying to find C. Okay, so we know one point, and we know the midpoint, and we're trying to find the other point. So basically, this point is unknown. Okay, this point is 3, 1. This point is 2, -5. And this point C is unknown. And so what we're going to do is we're going to add the x's. So we know one of them is 3, and one of them is just x. And you divide by 2. And since we already know the answer is 2, we set that equal to 2. So 3 plus x over 2 equals 2. what I'm going to do then is times both sides by 2. And so that will cancel out this 2. So now I have 3 plus x equals 4. Subtract 3, and you have x equals 1. Okay, and then, sorry, not sure what happened there. Okay, we're going to do the same thing with the y's. So I know one of the y's is 1. One of the y's is missing. I divide by 2, and I know the answer should be -5. Okay, so again, I times both sides by 2, and then I subtract 1, and so that answer would be 1, -11. Alright, now really the only other thing in this section is the distance formula. So finding the distance between 2 points. And so it's kind of a long formula. It looks like this. It's a big square root. You subtract the x's and you square it. And then there's a plus. And then you subtract the y's and you square that. Okay, so let me show you an example. So let's say you had the points 2, 5, and -3, 1. And you want to find the distance between those 2 points. Alright, so I set up a big square root. I subtract my x's. It doesn't really even matter which order you do it in. So, but if you want to go exactly by the formula, let's say for example this is x1, y1, x2, y2. Okay, so if we go exactly by the formula, we would go -3 minus 1 squared plus 1 minus 5 squared. So -3 minus 1 is -4 squared. 1 minus 5 just happens to also be -4 squared. And so it's 16 plus 16 is 32. Now you have to read the directions when you get into My Math Lab. They may just accept square root of 32. They might say turn it into a decimal. So in that case, you would just punch it into your calculator. Or they might do this. What you can do with some square roots is if there's a perfect square inside that number, like in this case 16. See, 16 times 2 is still 32, right? And we know the square root of 16 is 4. And so this would be another way to write that answer. So 4 square root of 2. Let me just show you one or two more like that, just in case you're not familiar with that. Like let's say you had the square root of 12. And so I know 12 is 4 times 3. And so that answer would be 2 square root of 3. Now it doesn't work with every number. Like if you had square root of 14, that's it. You don't break it up like this, although this is true, but it doesn't do you any good because there's no perfect squares in there. So this is true, but in that case you would actually just leave it like that. You wouldn't bother doing this. Okay, so let me just show you one more. Let's say you had 27. And so I know that's 9 times 3. And so the answer would be 3 square root of 3. Okay. Now, actually, let me show you one last one. Let's say you had 72. Sometimes people have a little trouble with this. And so the first thing you might think is, well, 9 times 8. And that's true. And so it would be 3 square root of 8. The problem is there's still a perfect square inside that 8. So that 8 has to get broken up as a 4 and a 2. And so now I have 3 times 2 times square root of 2, which is 6 square root of 2. Now one thing maybe you noticed already, there was actually a better way to do this problem. 36 in 2, and then I finish it in one step. Okay, so if you can find the largest square, you can finish the problem up in one step.